Good morning. Pleased to be with you. And we are going to be talking about how CBX has an effect on our environment. And more particular, I'm going to focus on the soil portion of the environment. And so we're going to go through several of these slides showing you the mechanisms, how it works, and why it works. Okay? And so to get started, we're going to go through what we declare it is not an invention, but a discovery. Invention means that you take things from a part and bring out a new item that hasn't been done in the market before. This is a discovery of elements that has already been in the earth a long time ago. We just lost them. What we're trying to do is bring back what the earth used to be like. And what we've done, we found a deposit of ancient plant material that allowed us to do that. And so we're going to go through how this got started. Why did we come into this idea? This idea has been advanced a long time ago, but we're going to give some credit to people who advanced the theories. A guy named Linus Pauling. He is two times Nobel Prize winner. And basically he discovered that every disease can be traced back to the nutritional deficiency. That's in humans, animals, plants, and soil. And so if we don't have nutrition for any of these elements, we will lose to the diseases that come into those environments. There's a man who is called Watson, who published a book called Principles of Soil Microbiology, and that is the foundation which we used to found our concepts and the products that we have developed today. In his book, he had two paths to get to productivity. One was called the synthetic method, or manufacturing elements that the plant needs. It's synthetic, and it can become antibiotic, in other words, kills biologies. Or they can use the organic recycling, which is called probiotic. The recycling takes a lot longer time and more effort. So the industry chose the synthetic because you can manufacture it, patent it, and make a lot of money on it. That was the mechanism that the society or the industry chose. So in our process of learning how to work this material, you'll see a photo on the left, and we'll get more details. It's called a deposit of lignardite. And what a lignardite is, and we'll go into some more description, is ancient plant material buried. This material, over time, compressed with a lot of pressure, will turn to coal. But there's several deposits in the world that didn't turn to coal. There's ancient composts sitting there of plant material from an era long centuries ago. So in that deposit are some unique elements. So we've taken that material. At the beginning, we used the material directly like a compost. The industry have lots of compost operations going out there, taking waste, put it in a compost, biologically break it down, and put it on the soil, and that's how they're doing. We thought well, that would do the same thing. But because this is so ancient, all the biology in there is dormant. Where current deposits of compost is active, that is not active. They're all suppressed and just waiting to go to work. But they're not useful right now because you put it on the soil, it takes a long time to get it back to operation. But over time, we tested on different crops and fields and animals, and we discovered lots of things took place. So we're going to talk about all these avenues, the effect of what in that deposit and what took place. And here's what we're going to be talking about. We're going to talk about, by using the material that we extracted out of that deposit, we find higher yields, a dramatic improvement of SRDs, and this is a measurement of what they call the broad spectrum of biologies. You can't have a single biology. The soil needs total broad spectrum biology because each little entity has a different effect on the soil by extracting inorganic minerals and making it organic for the plants. So the greater the number, the more healthy and more fertile the soil. We have proven that by using it, we get water savings. In the desert, it's very important. When you have lots of moisture, you don't need that much moisture, but it also opens up the soil so the moisture is not going to be held there. So it changes the whole dynamics of the soil and water. In areas where there's salt, we already know that you have a high organic material in the soil, you can control the salts. Where there are salt problems is because they don't have a high organic matter and the salts are taking over the soil. And so we can show that we'll actually control the salts. We can reduce the fertilizer requirements for the plants. If you take care of the soil, the life of the soil can release many of the nutrients or almost all the nutrients that the plant needs. But because of the agricultural practices, the farming industry went to synthetic, which is what they call salt-based fertilizers. It ruined our soil biology. And so once you get started on chemical fertilizers, it's very hard to get off. It's like a drug. You have to keep feeding it more and more, trying to get the same results. And so when you have to change that, there takes a change from synthetic to the organic, and this is what we're going to talk about, or soil life. We have standing water. We have proven that we're taking this material in areas there's lots of water logging soils, we call it. We can open up the soils and literally the water can dissipate. We've got demonstrations on that. Activate reclaimed water. In the desert, where we developed all these products, one of the problems they do is water conservation, and they recycle it from wastewater. But wastewater has a lot of salts, and so we can reclaim that and make it useful for growing golf courses in Arizona in particular. When a healthy soil is healthy, of course, the diseases and the fungus problems reduce. In fact, if you get a really healthy soil, you don't have a lot of diseases. So that's our target, is increase those. We reduce the needs of pesticides. We have a golf course out in Arizona. They're using a lot of pesticide. Once we got that course turned over, he literally eliminated all his pesticides because the biology in the soil can take care of many of the pests. Composting, for composting operation, we can accelerate that. It's just simply biology does that. Water penetration, again in the desert, compacted soils or waterlogged soils, you open up the soil and the water goes in deeper so the roots can chase the water, and consequently we can reduce the water needs. Soil structure, which is similar, we restructure it because of biology. Because of the biology change in the soil, we can open up the soil, the roots get deeper and spread out, which means they can pull in nutrients from a greater area, requiring less nutrients to put on top. And then we increase the organic matter, let's say crop residue, we can break it down faster. Today, some of the farming industries have a problem of this organic breakdown by plowing their crop back under. Because there's so little biology in, the crop stays there for a year or more and it interferes for the next crop season. So that's an issue that's out there. And sometimes they used to burn them off, the crop. Now they take it off and haul it away and compost it outside. And so you took away all the organic matter that fed the biology of the soil. So the whole system is going downhill because of their practices. All because of the synthetic fertilizers had the control of the agriculture industry. So that's our approach. We are changing that under the concept that if we take a live soil and make it healthy, it will take care of all the other problems that the grower wants to need. And so